This is the math that made a perfectly smart person stare at a wall of symbols and quietly give up. Not because they were dumb, because somebody handed them a wall of squiggles before anyone told them the one secret that makes all of it click. It's this. Regular math takes a photo, calculus shoots the video, and that one idea is about to fix calculus for you, permanently. Regular math is great at things that hold still. Drive 60 miles an hour for 2 hours, you go 120 miles. 60 times 2, done. The sign is smug about it, look at it. But now make the speed change. You speed up, you hit traffic, you crawl, you floor it. And the smug little sign catches fire. 60 times 2 is useless now because there's no single speed to multiply. Here's the thing, the world forgot to mention. The real world refuses to hold still. A photo can't measure something that's moving. You need the video. You need to watch it change. So here's the whole plan. Calculus is just 6 tricks for reading that video, 1 frame at a time. And the last trick is a genuine magic trick. Hold on for it. It's worth the wait. Let's read the first frame. Trick 1. Open a map. Look at a curvy road. It bends all over the place. Now, zoom in. The curve looks a little straighter. Zoom in more, straighter. Keep going, zoom in like a maniac. And eventually, on that tiny patch, the curve isn't curvy anymore. It's just a line. That zoom forever move has a name. It's called a limit. A limit asks one question. What is this heading toward as I zoom in forever? Not where it is, where it's aiming. That difference is the whole trick, so let me make it stupid. Meet our runner. He wants the cookie. Rule of his cursed little universe. Each step, he only covers half the remaining distance. So he gets closer and closer. Halfway, then half of that, then half of that. He gets infinitely close to the cookie, practically touching it. So close you'd swear he had it, but he never grabs it. He's heading toward the cookie forever without arriving. That cookie is the limit, the place it's all heading. Remember that gap, that tiny, never zero gap. We come back to it, and it ruins his whole day. Trick 1, done. On to the good stuff. Trick 2. Your phone says 40%. Cool. Is that fine? Total mystery. 40% is either 2 more hours of peace, or it dies mid-text and ruins your life. The number alone is useless. The thing you actually desperately want to know is, how fast is it dropping right now? That word. Now. How fast? This exact instant. Hold on to that. It's the entire act. New scene. A dash cam. You hit pause. The clock freezes at 3:42 p.m. The car on screen is dead still. So here's a question that sounds insane. How fast is that frozen car going? It's paused. It's not moving. And yet the answer isn't 0. It was going 37 miles an hour at the instant you froze it. The tool that pulls a real speed out of one frozen frame has a name. It's the derivative. The derivative is the pause button. You freeze one single frame of the video, and it reads you the speedometer. That's it. Pause. Read the speed. And most people stop there, thinking the derivative is just one number. Here's the upgrade that actually breaks brains. The derivative isn't one number. It's a whole new video. Feed it your Where Am I video, and it hands you back a brand new How Fast Am I video. A speed for every single frame. Position video goes in. Speed video comes out. One whole movie becomes another whole movie. That's the real trick. But to actually build that machine, we hit a wall. And it's our cookie runner's tiny gap again. To read speed at one instant, you compare 2 frames a tiny moment apart. That gap is the cookie distance. Infinitely close to 0. And here's the trap. The gap is so unbelievably small, you'd love to just call it 0 and be done. But if you call it actually 0, it disappears. Divide by it and the whole thing blows up. He grabs air, same as the cookie. So the limit does the impossible thing for you. It holds that gap infinitely close to 0 without ever letting it be 0. Never grabbing the cookie is exactly the point. So that's pause. Now let's hit play. Trick 3. You did a workout. In your memory, you were a machine. Sprinting. Unstoppable. A beast. So let's roll the real tape. The board rewinds it for us. Let's see the actual footage. Minute 1. A sad little walk. Barely moving. Minute 2. A wheezing jog. Generous to even call it that. Minute 3. Okay, one real sprint. For about 9 seconds. We'll allow it. So the rate was different every single minute. Which means you can't just multiply speed by time anymore. The smug sign is still on fire. Remember? So you do the only honest thing. You chop the workout into tiny pieces, a tiny slice where the speed barely changes, and you add every piece up. The tool that adds up all those tiny pieces is the integral. If the derivative was pause, the integral is play it all back and total it up. Let me make it rain. Literally. Minute 1, a light drizzle. The bucket barely fills. Minute 2, the sky opens. Total downpour. Our boy is drenched. The bucket fills fast. Minute 3, back to a drizzle. The rain rate changed the whole time. So how much water is in that bucket total? Draw the rain rate as a curve. Low, then high, then low. And the total water, the answer to the whole question, is the area underneath that curve. Watch the board shaded in. That's it. That shaded in area is the answer. The integral is just the area under the curve. Add up the rain, get the water. Now, one honest catch, because I refuse to lie to you. I said we chop it into slices, but chunky slices leave little gaps. So you imagine the slices getting infinitely thin, infinitely many, infinitely skinny. In the limit, our zoom forever friend again. The gaps vanish and the slices hug the curve perfectly. The integral sums infinitely thin slices, not chunky frames. So, pause reads one frame. Play and add gives you the area of the whole thing. Two tools, total opposites. One freezes a single frame. The other watches every frame and totals them. Couldn't be more different, right? Remember ticket 6? The magic trick? It's time. We've got two machines that look like sworn enemies. Freeze one frame, play it all, and add it up. Plot twist. They are the exact same machine. One just runs in reverse. You already know this pattern. +5 and -5. Times and divide. Pairs that perfectly undo each other. Watch it loop. Start with your position video, where you are. Pause it with the derivative. Out pops your speed video. Now take that speed video and play and add it with the integral. Total up all the speed, and you land back perfectly on the exact position video you started with. Add up all your speeds, and you get exactly how far you went. Pause and play and add aren't opposites. They undo each other. That's the whole magic trick. It has a grand name, the Fundamental Theorem of Calculus. Fancy words for the pause button and the play button are the same gadget, flipped. Two guys figured this out separately over 300 years ago, then spent years fighting about who did it first. It was a whole drama. But the idea is the gift. Take a movie apart into instants. Add the instance back up, get the movie, forward and reverse. One machine. That's the secret the squiggle wall was hiding the whole time. You've got it now. Which raises a creepy little question. Where is this thing actually running? Everywhere. Watching you. Right now. Your phone's 2 hours of battery left? That's a derivative. It reads how fast your charge is dropping and pauses on the rate. The OS smooths and guesses too, but the bones of it are calculus. Your GPS telling you how far you drove, that's an integral. It takes your speed and adds up tiny slices of motion to total your distance. And every AI you've ever used, it learned by tumbling down a hill, taking the derivative to find which way is downhill, and stepping that way, over and over, until it stops being wrong. They call it gradient descent. It's just a robot rolling downhill using derivatives. That single trick trained basically all of modern AI. So here's the channel's whole point, drawn small. Calculus isn't a wall of squiggles. It's a quiet machine, running in the background, measuring you every single second. Your battery, your route, the apps learning your habits. All of it watching the video of you, pausing it, adding it up. Photo to video, pause to read the speed, play to add the area. And the two are the same machine in reverse. That's calculus, the whole thing. And our crash test student? He finally gets it. Watch, he's gonna write the formula himself. He grabs the marker, presses down to write his first real. If you want the proof the GPS thing actually works, that one's even weirder. It's right there.